Before we flip over to the next page, I just want to make sure everybody got all this down. I know I was kind of flying. I was watching the recording wind down, so I was trying to get it all done. But this might be the pieces that you didn't get, and I just over here labeled the points so you could see where those came from. So when I went down 3 over 2, that was the 0.25, and then when I went down 3 over 2, that was the 0.42, and then when I went down 3 over 2 again, that was 6, -1. And the first point was already listed, so that's why I didn't list it again. And we could have also labeled that one as 5 1/3 0. Let's go ahead and do that just so you can see the visual. So that one was 5 1/3 0. So we got lots of points on that line. Okay, let's go ahead and turn over to page 4. This looks like a long, oh no, it's a couple short problems. So, page 4 of lesson 4B, we have, it looks like an activity with hot dogs, movie tickets, and a bike ride. So at a concession stand, and this is kind of getting you ready for what we do at the very end, we're going to be using 2 variables. So this is kind of like not a lead in because it's not our next thing, but just practice. So 3 hot dogs and 5 sodas cost $18.50. So we're going to do H as the hot dogs and S as the price of each soda. And we're going to write a linear equation in standard form, ax plus by equals c, and represent our variables. So we already know what h is. H equals the cost of a hot dog. And it says represent your variables, so make sure anytime it says that, you write your variable statement, use the letter, tell what it stands for, then give the units, dollars. And S is the cost of each soda, or cost of a soda. And that also would have a units of dollars. So that's what represent your variables first mean. And usually on every word problem, we have you do that first. After that, love these problems. It's just a straight on translation. When you see hot dog, you put in an H. When you see soda, you put in an S. So 3 hot dogs, and that's plus 5 sodas cost $18.50. That's how easy it is to write your equation. Translate it word for word. So tell what variables you're going to use, and then when you see the word hot dog, put in H. When you see the word soda, put in S, which I don't really like to use because it gets mixed up with a 5, but we do what we have to do, right? If the hot dog costs $3.25 each, so that's what they're telling us, because H is the cost of a hot dog, how much is a soda? Well, we just work it out. So 3 times 3.25 plus 5S equals $18.50. So we're solving for S. So what would that be, $9.75? It is, but I'm going to be a good student and check my work. Yes. So 9.75 plus 5S equals $18.50. So I'm solving for S, which means I need everything without an S over. So minus 9.75 minus 9.75. And we're going to get 5S equals, looks like it's going to be 875 maybe. So type this into your calculator. So 18.50 minus 9.75 equals 875. Let's keep the calculator there because we're going to need it on the next step. And then to find the cost of one soda, we have to divide by 5 to find out what 1S is. So the cost of a soda is Keep your $8.75 there and just hit divided by 5. Boom, $1.75 for a soda. And I believe that's what they asked for. Yes, how much is each soda? So why don't you shut off the video and try to do the next one? Same thing. It's just adults and children's instead of hot dogs and sodas. So see if you can do the next one. And then join me to check it. Okay, so 3D tickets. The cost of a ticket to a 3D movie is $12.50 for adults, $8.50 for children. I think I'm going to use a different color to underline it just so it shows. Orange would be a good one. So $12.50 for adults, $8.50 for children. 932 was collected. So A is the number of adults, C is the number of children. So represent your variables first. So A equals number of adults and C equals number of children. So to get the total cost, we have to take $12.50 times how many adults went plus $8.50 times how many children went and set that equal to the total that was collected. So our equation is going to be, and you can translate it word for word, $12.50. I see the word adult, so I put an A. And again means addition in this $8.50. I see the word children, so I put a C. And then it says the total. That means you're setting it equal to 932. So once again, another direct translation. When you see adults, plug in an A. When you see children, plug in a C. And that would be my equation. 17 children's tickets were sold. So that means they want us to put 17 right there. So we'll have $12.50 So you can tell we're definitely solving for A here, plus $8.50 times 17 equals 932. So this time I need to solve for A to get A all alone. So let's do $8.50 times 17 first. So 8.50 times 17, 144.5. So we have $12.50 plus 144.5 equals 932. So just like on the last one, we need anything without an A over to the other side. So that means subtract, because I'm crossing the equal sign, 144.5, subtract 144.5. And then we'll get 12.50A equals, so 932 minus 144.5. Oops, I forgot my point. 0.5. 787.5. But with that still on the screen, now we need to divide by 12.50, divide by 12.50, and we have A equals 63. So then we could write 63 adults attended. Not bad, right? So if you want, go ahead and turn off the video again and try the last one. It's the same old, same old. They give you the formula to use, rate times time. Okay, so on this one, we have John's going on a 50-mile ride. That's important because that's what we're going to set it equal to find the total distance. His bike chain broke and he is forced to walk the rest of the way. John walks at a rate of 4 miles per hour and he rides at a rate of 18 miles per hour. So B is the amount of time in hours John spent biking. So we could write B equals biking time, and then we just have to say that it is hours. And then it says W is the amount of time walking. So W equals walking time in hours. So let's see. Write a linear equation in general form to represent this situation. So rate times time. So we need to look at the bike. What was the rate? 18 times the time spent biking, B. So I'm just following this formula. The distance equals rate times time. So the rate of the bicycling was 18. The time of the bicycling was B. So just using that formula. Plus, then he walked. The rate of his walking was 4 times the time walking, W, and together the distance of the bike plus the distance of the walk is going to be the total distance, which is 50. So that was really wordy, but it was nice that they gave you this formula. So rate times time of the bike, that's the distance biking. Rate times time of the walking, that's the distance walking. Together, the two distances equal a total of 50 miles. So it says, assume John has been riding his bike for 2 hours. So now you can see why we pick letters that mean what we're talking about. A for adults, C for children, B for bike, W for walk. Because if we used X and Y, we wouldn't know whether to plug in for X or for Y. So we always use letters that represent what we're talking about. H for hot dog, S for soda. So let's go ahead and solve this. 18 times 2 plus 4W equals 50. So 36 plus 4W equals 50. And we need that over there. So subtract 36, and we get 4W equals, what is that? I think it's 14. 50 minus 36. Yep. So I just put the B there, replaced the B with 2, got 36. Then I need to bring everything except for the W over to the right, so do the opposite. And then my last step is to divide by 4. Divide by 4, divide by 4. So remember, W is his walking time, and that's why we love having this there, because it tells us what we just found. Is it the speed walking? Is it the time walking? Is it in minutes? Is it in seconds? We have it all written there, so we don't have to read the whole problem again. So 14 divided by 4 is 3.5. And you could write 3.5 or 3.5. It doesn't matter. It's a nice decimal, so a decimal's fine. So 3.5 what? We look up here. Hours walking. So solve the equation for W, move everything over to the other side, And then once you find your answer,